Okay, so today's topic is, guys, Ether channel. Anyone can tell me what is the use of Ether channel and why we use the Ether channel? Okay, so before use of Ether channel, first of all, we will discuss what is the problem with the STP. What is the problem with STP? Understand? When we understand the problem, then we will go for the solution. Clear, everyone?
Yes.
Now, see the problem. For example, this is the switch number 1. This is the switch number 2. How many switches are there, guys? 2 switches are there. Okay. Let's suppose between these 2 switches, multiple links are connected, and this is very common. Let's suppose we are using how many links, guys? 4 links. So between switch number 1 and switch number 2, how many links are there? Total
4
links is there. By default, and on every switches STP is enabled. Yes or no? Yes.
Yes.
STP is enabled. It means among these 2 switches, one switches will become the root bridge and one switches will become the non-root bridge. Yes or no?
Yes.
Yes.
Yeah.
For example, switch number 1 is root bridge and switch number 2 is non-root bridge. Clear? So if this is the root bridge, it means all the port is DP port. Right? Everyone.
Yes.
You know these things. All the port is DP port. Clear? And here on switch number 2, one port will become the RP port.
RP.
Rest all the port will become block port.
Block port.
Yes, na everyone? Are you understand?
Yes.
Okay. So this port, now on any switch, only one port will become the RP port. So this port is RP. Can we make this port DP? No, this is not possible because on this link, on single link, DP is not possible. Right? Na? So this is DP, so it cannot be DP. So if this port cannot be DP and not RP, then last one is block. So these ports are block port. Clear? Everyone, tell me. It's clear to all of you? Now, for example, here one PC number 1 is connected and here one PC number 2 is connected. So if PC number 1 will send any packet will reach on switch. What switch will do? Switch will forward this packet through
DP.
this link. Yes or no? Everyone, tell me. Just a minute.
Yes.
Just give me a minute, guys. Just.
Yeah.
Am I audible? Sorry, guys.
Yes, sir. Yes, sir.
So, in today class, what we are going to discuss, guys, we are actually going to discuss Ether channel, right? Okay. In Ether channel, before we start, guys, Ether channel, first of all, we will discuss what is the problem with the STP, right? Because in previous classes, we already discussed about the STP. Yes, na everyone? Yes.
Yes.
So, first of all, we are going to discuss what was the problem in STP. So once we understand what is the problem with STP, then we will go for the solution. Getting my point, everyone? So first of all, focus on the problem. Once you guys will understand the problem, then definitely you guys will understand the solution as well. Clear? Are you telling me yes, na everyone?
Yes. Yes.
Okay. See here. For example, if we have a switch number 1 and switch number 2, and let's suppose there are multiple links between switch number 1 and switch number 2. There are multiple links between switch number 1 and switch number 2. Clear, everyone? Now, and this is quite frequent in the real environment also. Getting my point, everyone? Understand, na? This is quite frequent. If you remember, I told you, na, let's suppose this is the access layer switch, and this access layer, with this access layer switch, there are multiple end users are connected. Yes or no, everyone? Yes, everyone, right?
Yes.
Now, and if you remember, I told you in your switch there are one network module. Yes or no? Yes. And through the network module, if you remember, I already show you the diagram also, guys, as well as the images also. Through the network module, these network modules is known as, in real environment, this is known as, guys, uplink. What is uplink? In real network, now this is known as uplink. Clear? So this is the access layer, and after that I told you there is a which layer, guys? Distribution layer. In distribution layer switch, again there will be a network module. Okay, and in this network module, again there will be a multiple uplink. Yes or no? Yes. And in real environment, what is connected through this port? Through this port, fiber cable is connected. What is, guys? Fiber cable is connected. Getting my point, everyone? So let's suppose how many fiber links is connected here? 4. How many fiber links are connected? 4. Getting my point, everyone? Tell me yes or no. Yes, na?
Yes.
4 links are there. So same way I told you, how many links are there? 4 links are there. What is the use of that fiber link? This fiber link send your all end users traffic where? At distribution layer. Clear, everyone? Understand?
Yes.
Not only this, for example, let's suppose I'm giving you one scenario of one of the MNCs. For example, this is the switch number 1. This is the L3 switch. Okay, na? Switch number 2. And these are the distribution layer switch. And let's suppose on this company, there are multiple floors. What? Multiple floors are there. And on multiple floors, let's suppose on each floor, there are more than 200 users are there. So definitely there will be a multiple number of switches, because in one switch, max to max, how many ports will be there? 48. Yes or no?
Yes.
Yes. But on each floor, how many users are there? More than 200. So definitely on each floor, there will be a number of switches. Do you understand, everyone? Yes or no? Yes. In maximum scenario, you guys will see switches are in stack. Switches are in stack. What is stack? How we configure stack and how stack will behave. Everything we already discussed these things. But see here, let's suppose if multiple floors are there, multiple stacks are there. But for every stack, there will be a fiber cable. There will be a fiber cable. And this fiber cable is connected with your DR router. Let's suppose this is designated router, DR router. This is the distribution layer. Getting my point, everyone? Yes or no? Yes.
Yes.
Tell me yes, na? So
Yes.
for every access switch, for every access, how many DRs are there? There are 2 DR. Let's suppose this is my DR number 1 and this is my DR number 2. And among these 2 DR, one DR will be our primary DR and one DR will be our secondary DR. For example, this is my primary and this is our secondary. And when the uplink is connected, let's suppose through this switch 2 uplinks are there. So one uplink is connected with your DR1 and one uplink is connected with your DR2. Getting my point, everyone? So by which
Yes.
by which you can achieve the redundancy.
Redundancy.
Right now, when one link will fail, you have the other DR. Clear, everyone?
Yes.
Now, one more thing. Let's suppose if this link will fail, you have other link. But guys, between the DR, again, there will be a connectivity. Understand, everyone? Between the DR, again, there will be a connectivity. For example, between the DR, how many links are there? 4 links are there. Getting my point? Again, here what we use? Ether.
Ether channel.
And this type of topology you guys will get in maximum MNCs. In maximum MNCs, you guys will get these type of topologies. Getting my point? So in between the DR, there will be a number of link. Getting my point, everyone? And where we are using what? Ether channel. Clear? I hope you guys understand very well.
Yes.
Clear? Now the thing is, what is the problem? Problem means, what is the problem with the STP? Now, think guys, here how many switches are there guys? 2 switches are there. And by default, STP is configured on the switches. Yes or no? Yes?
Yes.
So here also STP is enabled and here also STP is enabled. And we already know in our STP classes, among these 2 switches, one switches will become the root bridge. Yes, everyone. For example, the MAC address of switch number 1 is A and MAC address is B. What is the priority? 3, 2, 7, 6, 8 plus A. Yes or no? Yes. What is the priority? 3, 2, 7, 6, 8 plus B. Understand, everyone? Yes or no? Yes. When this both switch will up, both switch start exchanging the BPDU. You know, na, everyone? BPDU. Yes. So when both switches start exchanging the BPDU, and I already told you one more thing. Until the election will not happen, both switch will understand I am the boss. Yes or no, everyone? Yes. But when both switches exchange the BPDU, it means switch number 1 have how many BPDU? 2 BPDU. First, itself BPDU and switch number 2 BPDU. Yes or no? Yes. And switch number 2 also have how many BPDU? 2 BPDU. Switch number 2 itself BPDU and switch number 1 BPDU. Getting my point, everyone? Yes or no? Yes.
Yes.
Both switches compare the BPDU. Understand? And both switches try to figure out which BPDU is superior. Which BPDU is superior? There are 2 types of BPDU, superior and inferior. Yes, na? The switch which has the superior BPDU, that switch will become the root bridge. Getting my point, everyone? These things we already discussed, right? Superior BPDU means the bridge which has the lowest MAC address. Yes or no? Yes. Basically, by default, priority is already set na 32768. It means here and here priority is tie. Priority is tie. Now both switch compare what? MAC address. So the switch which has the lower MAC address, that switch will become the root bridge. So it means among switch number 1 and switch number 2, who will become the root bridge, guys? Switch number 1 will become the root bridge. Clear? Anyone who do not understand? It's clear to all of you? Everyone? Guys, clear?
Yes.
Now,
Yes.
come on the port role. When root bridge is decided, it means this is switch number 1 is the root bridge and switch number 2 is called non-root bridge. Clear, everyone?
Yes.
Clear? Now, on root bridge, we already know what is the port role. Every port of the root bridge is called DP port. We already know, right, everyone? So this port is the DP, this port is the DP, this port is the DP, and this port is the DP port. Yes or no? Yes? Now,
Yes.
come on the non-root bridge. On non-root bridge, one port will become the RP port and rest all the port is blocking port. Yes or no? Everyone. Yes? Because
Yes.
I already told you not two rule. First rule is on one switch, there will be only one root port. Yes or no? Yes. So one root port is
Yes.
already elected, right? Second root port is not possible on switch number 2. Second rule I told you, on a single link, DP, DP, RP, RP, not possible because it will create what? Loop. Yes, na everyone? Yes or no? Yes.
Yes.
And this is the functionality of STP to avoid these things. Yes, na? This is the functionality of STP to avoid these things. And I already show you practically when I disable the STP. Then what happened? Every port is in which state? Forwarding state. Right? It means through every port switches are forwarding the packet. And what is the problem there? There was a problem with collision, loop, everything. Yes or no? Yes.
Yes.
So when we configure the STP, what STP did, guys? STP just block all the alternate path. Yes or no? Alternate
Yes.
path and choose the best path to reach the destination. And when one link will fail, the other path will active. Yes or no? Yes. So that's the reason, if you remember, I told you what is the main use of STP. Not only to avoid the loop, because everyone know to avoid the loop. No, there is no. This is the traditional to avoid the loop. STP avoid the loop. This is true. There is no problem. But STP also provide the what? Redundancy. What, guys? Redundancy. Getting my point, everyone? Yes or no? Yes?
Yes.
So
Yes.
here this port will become the root port and all the other port will become the non-root port, or you can say which port? Blocking port or alternate port. Clear, everyone? Now the thing is, for example, if we connect one PC number 1 here, and here I connect PC number 2. Clear? Let's suppose if PC number 1 send any traffic, packet will reach where, guys? On switch number 1. Yes or no? Yes?
Yes.
So when this traffic will reach on switch number 1, what switch number 1 will do? Switch number 1 will forward this traffic through which interface? Tell me. Which interface?
The first interface is on the top.
Okay, let's suppose if this is the broadcast traffic. So what switch will do? Switch will forward, because all the ports are in the which state? Forwarding state? Yes or no? Yes?
Yes.
So this port of the switch will receive it and all the rest port will discard it. Yes or no? Yes? When this PC number 2 will send the reply, packet will reach on switch number 2 and switch number 2 forward this reply through this link. Yes or no? Everyone, tell me. Yes? It means whatever the communication will happen between PC number 1 and PC number 2, all the communication will go only by this link. Because these links are useless. Yes or no, everyone? Yes?
Yes.
Because what STP did? STP just move these port in which state? Blocking state. It means all the traffic is going, coming, everything happening only by this link. Yes or no, everyone? Yes.
Yes.
Now the question is, sir, if we have a 4 link, but we are utilizing only 1 link, then why we are connecting these 4 link? These are useless. Yes or no, everyone?
Yes.
These are
Yes.
useless. For example, this link bandwidth, we are using the fast Ethernet link. So what is the bandwidth? 100 Mbps, 100, 100, 100. Right or wrong? Right, everyone? So let's suppose
Yes.
if you are sending here, so it means 100 Mbps here. And if packet will come, so it means 100 Mbps here. It means total efficiency you guys are getting how much? 100 plus 100, how much? 200 Mbps you guys are getting total efficiency. Yes or no? Yes?
Yes.
Can you tell me? Yes, na?
Yes.
How many
Yes.
efficiency you guys are getting? 200 Mbps. But let's suppose if all the link will be active, just assume if all the link will be active, how many efficiency you guys will get? 200 for this link, 200 for this link, 200, 200. So 200 into 4, how much? 800 Mbps. Yes or no? Everyone tell me. Yes? It means if we have a multiple link and if there is a STP by default configure, so what is the problem? Problem is we are not getting the proper efficiency. We are not getting the proper efficiency. Yes or no? Yes. So that's the reason we want any protocol or anything by which we can get the maximum efficiency. Yes or no? Everyone, tell me. Yes?
Yes.
So this is the problem in STP, yes or no? Yes, na? This is the problem. Tell me at least yes or no. Understand,
Yes.
everyone? So that
Yes.
is
Yes, sir.
solve these problems so we can get the maximum efficiency. Am I audible, guys?
Yes.
Yes, sir. Now.
Okay, cool. So I hope you guys understand what is the problem with STP. Yes or no? Yes, na?
Yes.
So
Yes.
that's the reason to avoid these type of challenges, we need a certain types of protocol or technology by which we can get the maximum number of efficiency. Otherwise, let's suppose if you are using the 4 link, then but you are utilizing how much? Only 1 link. And you are getting the efficiency from only 1 link. Yes or no? Yes. So it means these links are complete waste or useless. Right
Yes.
now. So to solve
Yes.
these problem, we need any protocol or any technology which can solve these problem. Clear, everyone? So that's the reason we have a concept of what? Ether channel.
Channel.
Understand, everyone? I hope you guys understand the overview,
Yes.
why we
Yes.
need the Ether channel and what is the problem and how what Ether channel will going to solve. Clear, everyone?
Yes.
Now,
Yes.
the first thing, what is Ether channel. Anyone? Anyone know something? What do you mean by?
Port aggregation.
Okay. Do you guys know something?
Aggregation.
Okay. So I'm getting one answer. It is used to bundle more than one physical link into a
Single.
logical link. What I write, guys? It is used to bundle more than one physical link into a logical link. It means, what do you mean by it? It means if you have a switch number 1 and switch number 2, and if you have a how many links? Let's suppose 4 links. How many links, guys? 4 link. So it means physically how many links you have? Physically you have how many links, guys? 4 links. Are physically how many links you have? 4 links.
Four.
But by the help of ether channel, we will bundle all the 4 links and create only one single logical link.
Link.
That is ether channel.
Ether channel.
That is ether channel. Clear, everyone? Understand?
Yes.
Aggregation.
It means we can say one thing. We can say one thing. If we have a 2 switch and if we connect the multiple links here, if we connect the multiple links here, and by default what is running here, guys? STP is running, and these links, this link is in forwarding state and these links are in which state? Blocking state, or you can say these links are useless link. Right now, everyone? Yes or no? Yes.
Yes.
So that's the reason we want ether channel. We want ether channel solve this problem. How? What ether channel will do? Ether channel make all the link in which state? Forwarding state.
Forward.
Right? Na? We want this solution because how many links you guys are using? 4 links. So you want na all the 4 links will be in the forwarding state. Yes or no? Because physically how many links you guys are connected? 4 links are connected. So if you guys are getting all the 4 links in the forwarding state, then you guys will get the maximum efficiency. Yes or no? Yes.
Yes.
So
Yes.
that's the reason
Yes.
we want ether channel will make all the 4 link in which state? Forwarding state, not in blocking state. Clear, everyone? Understand?
Yes.
Yes.
Are you clear na, everyone? So
Yes.
basically we can say basically ether channel increase the efficiency or through output. Yes na?
Yes.
Traditionally if you are dependent on the STP, then you guys are not getting the maximum through output there. But if you are using the ether channel, what ether channel will do? Ether channel will convert all the 4 link in which state? Forwarding state. So you guys will get the maximum through output there. So you can say na ether channel provide the maximum through output. Clear, everyone?
Yes.
Understand na? Clear?
Yes.
Now the thing is how actually ether channel work. How actually the ether channel work. How ether channel work. See, for example, we have switch number 1 and switch number 2. Clear, everyone? We have 2 switch and there are 4 links are connected. Clear, everyone?
Yes.
Now
Yes.
let's suppose if we configure the ether channel here on switch number 1. When we configure the ether channel on switch number 1. Now tell me on switch number 1 how many ports are there? Total four
Four.
ports are there.
Four.
Yes, na everyone. Tell me.
Yes.
So when we configure the ether channel, what ether channel will do? Ether channel bundle all the four link into one logical,
Logical link.
or either you can say logical port, or either this is in ether channel terms that is called port channel, guys. If we are talking about the ether channel terms, then this is known as what? Port channel, or you can say port channel interface. Are you understand everyone? All the things are same.
Yes.
Clear everyone? So what I write here, when we configure the ether channel on switch number 1, what ether channel will do? Ether channel will convert all the four link, or ether channel will bundle all the four link and create one or convert into one logical link that is called port channel. What is called, guys? That is called port.
Ports. Yeah.
Understand everyone?
Yes.
Clear na? Or you can say port channel interface. Now this switch number 1 has only one interface. Only one interface, not four interface. Now switch number 1, think switch number 1 have how many interface? Only one.
One.
Array, this switch, think I have only one what? Logical interface.
Logical interface.
Logical interface, not for physical interface. Understand? And that logical interface is known as what? Port channel interface. Port channel interface. Clear everyone? I hope you guys understand. Clear now?
Understood.
Yes.
Okay. Now I hope you guys have clear port channel and what is port channel interface. Clear na? Port channel is just like a bundle, right? And thus the
Yes.
interface, there is a only one logical interface that is called port channel interface. Clear? So basically,
Yes.
when you write the ether channel command, guys, when you write the ether channel command, there it will ask you the group number. What it will ask you, the guys? Group number. Understand everyone? It will ask you the group number. Clear everyone?
Yes.
So what you have to do? You have to specify the group number also. You have to specify the group number. You have to specify what? Group number. Clear? So on the basis of that group number, your port channel interface will create. Port channel interface will create. Understand everyone? I will show you how actually we can. Getting my point, everyone? But right now, just understand what is group number. So when we configure the ether channel, it will ask you the group number. So you have to mention the group number. For every port channel, there will be a specific group number. Getting my point, everyone? Understand? Are tell me?
Yes.
Okay. It means when you configure, guys, here ether channel, so what ether channel did, guys? All the four physical link is converted into one logical link. Right na everyone? Yes or no? Yes,
Yes.
na? Or only one physical, logical interface that is called port channel interface. Now this switch is not thinking they have four physical interface. No, this switch is thinking how many interface they have? Only one.
One.
Only one.
One.
So it means four physical link is not matter here, guys. Only one port channel interface matter. Clear everyone?
Yes.
Clear na?
Yes.
Now the thing is, you guys will think, sir, here loop will create, yes or no? Here can loop will create or not?
No.
Yes, definitely. if you see this type of topology, definitely you guys can think, yes, loop will create. I can show you how. See. Tell me one thing. For example, if I connect here PC number 1, if I connect here PC number 2. Getting my point, everyone?
Yes.
Right now, what I did, I just bundle, na, everyone.
Yes.
I just bundle here. So now you guys can think, sir, let's suppose the PC number 1 send the packet, switch number 1 forward here, 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 here. Yes or no? Yes, na? So you are
Yes.
telling now there will be a not blocking port. So it means the same packet switch number 2 receive here, 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 here. And this is called a loop. I already told you when the same packet with the same MAC address which will receive on different interface, that type of situation is called loop.
Loop.
Yes or no? Everyone?
Yes.
Yes.
Yes, na? So you guys can think, sir, it will possible here when PC number 1 send, let's suppose any broadcast packet will reach on switch number 1 and switch number 1 forward through all the interface, and it means switch number 2 receive the same packet here, 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 here. It means on the different interface, switch number 2 is receiving the same packet. Are yes or no?
Yes.
Yes.
Yes, na? But no. Guys, tell me one thing. Right now, I told you when you configure the ether channel, all the 4 physical link convert into how many logical link?
One logical.
1 logical link.
Link.
It means now switch number 1 will forward your packet through only 1 link, guys.
One link.
Not all the 4 link. Not
Mhm.
all the 4 link. Getting my point, everyone? Do you guys understand? Yes or no?
Yes.
Understand? Now, again, you guys will ask, sir, you are telling PC number 1 will send the packet will reach on switch number 1. On switch number 1, we already configured the ether channel. So ether channel will decide among all the 4 physical link, ether channel will choose 1 link.
One link.
1 link, right na, everyone? Because all
Yes.
the 4 link is the part of logical link.
Logical link.
Right? So it means switch number 1 will decide among all the 4 physical link, there will be only single link. Guys, don't think like this, your packet will go in the air. Packet will travel by the link only.
Link
Okay,
only.
na? But ether channel will decide which link will be there. There will be only 1 link, not all the 4 link. Clear, everyone? I hope
Yes.
doubt is clear. Clear na, everyone? But
Yes.
Yes.
again, you guys will think, sir, you are telling switch number 1 will select the 1 logical link. But how and what will be that link? There will be 1 link, na? But how switch number 1 will select that link? Definitely there will be a certain criteria or parameter. Yes or no?
Yes.
Yes.
Yes, na? Yes, you guys are thinking right. Definitely there will be a criteria or parameter. On the basis of that parameters which will choose the 1 link, and that parameter and that process is known as what? Load balancing mechanism.
Mhm.
What is load balancing mechanism? Clear, everyone? I hope you guys understand. Clear?
Yes.
Switch
Yes.
number 1 will choose 1 link to forward the packet on the basis of load balancing mechanism. What is load balancing mechanism? How load balancing mechanism will work? We all discuss later. Getting my point, everyone? Till
Yes.
now,
Yes.
just understand switch will choose only 1 link, and that 1 link will be decided on the basis of load balancing mechanism. Clear, everyone? I hope it's clear to all of you.
Yes.
Everyone. Okay. Now, before this, we are discussing about the loop. Yes or no? Arey, tell me.
Yes.
Yes, now we are discussing loop. Guys, tell me one thing. I'm just giving you one scenario. Please think about this scenario. PC number 1 is there. PC number 2 is there. Okay, everyone. Arey, tell me.
Okay.
PC number 1 send the one broadcast packet, or let's suppose any packet. Packet will reach on switch number 1. Switch number 1 will forward this packet only by one link. Right? Na? Yes or no?
Yes.
So we already configured the ether channel. So for example, switch number 1 forward this packet through this link. Right? Everyone. On
Yes.
switch number 2 also you configure the ether channel. Yes or no? Yes. So
Yes.
if already you configure the ether channel, it means there is no concept of blocking. Right? Na?
Yes.
Yes. It means these links are not in the blocking state. All are in the forwarding state.
Forwarding
And
state.
tell me, yes or no? Yes.
Yes.
This is the, let's suppose ARP packet. This is the broadcast packet. Packet will reach on switch number 2. Just tell me one thing. What is the behavior of switch when switch receive any broadcast packet? Switch will forward that packet through all the interface, including the trunk port. Yes or no? Everyone, tell me.
Yes.
Yes,
Yes.
na? Yes. It means this switch number 2 forward this packet here, 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 here. Yes or no? Everyone, tell me.
Yes.
Understand? So
Yes.
it means these packet switch number 1 receive on these interface also. Yes or no? Tell me.
Yes.
Yes. It means this is type of loop or not? Yes. Definitely this is the type of loop. Why? Because guys, switch number 1 is forwarding the same packet through this interface. Switch number 1 is forwarding the same packet through this interface. And again, switch number 1 is receiving the same packet on these
Yes.
interface. It means this is loop. Yes or no? Everyone.
Yes.
Yes, na? Arey, tell me at least yes or no. Yes?
Yes.
Yes.
Yes, guys. This is called loop.
Loop.
So definitely in ether channel, if this type of situation will happen, that is called loop.
Loop.
But don't worry. In ether channel, there are some mechanism, or you can say there are some rule that is called loop avoidance mechanism. That is called loop avoidance mechanism. Are you getting my point, everyone? That is called loop avoidance mechanism. Clear, everyone?
Yes.
Okay. Now discuss what is loop avoidance mechanism. I hope now you guys understand how actually loops can create. Yes or no,
Yes.
everyone?
Yes.
Yes.
Okay. Very good. Now, when we see the problem, then we will discuss the solution. First of all, whenever you are working, first of all, understand the problem. So when you understand the problem, definitely you guys will understand the solution. Clear, everyone? Now,
Yes.
try to understand what is the solution. What is the solution? See here. I'm writing the rule here, guys. First of all, if you guys are writing, then please write the rule. Otherwise, please see the rule or think the rule very carefully. The rule is in ether channel, switch will not forward the packet through those port which is the part of same ether channel, sorry, port channel. This is the rule. Now think what is the rule. The rule is, guys, tell me one thing. You configure the ether channel here as well as you configure the ether channel here. Yes or no? Yes.
Yes.
So when you configure the ether channel here, what will happen? These all the 4 ports will convert into one logical port. Yes or no? And that is called port channel. Are yes or no? Yes, na?
Yes.
That is called port channel. Right? Everyone. Are tell me.
Yes.
Yes, na? Similarly, here you configure the ether channel. It means these all the 4 port will be part of one logical port, and that is called port channel. Yes or no? Na?
Yes.
Okay. I told you when you configure the port channel, you have to configure the group number. Yes, na everyone. These switch are directly connected and you are bundling all the 4 ports in one port channel. Right, na? It means definitely you guys will configure any group number. For example, I configure group number 10 here. Are yes or no? Yes, na?
Yes.
And again, these 4 ports is connected with the switch number 2. So again, you have to configure here same group number. Group number 10. Then ether channel will create, guys. It is not possible here. You configure the different group number and here different group number. No. Then it will not become the port channel. Getting the point, everyone? So what I did, guys, here I configure, let's suppose group number 10 and here I configure group number 10. It means this one and this one is the part of same port channel. Clear, everyone? Yes or no? Clear now?
Yes.
Yes.
What is the rule? The rule is if switch number 2 receive any packet on this interface, it means this interface is the part of which group number, guys? 10. Are you understand na? And again, these
Yes.
interface is also a part of same port channel. Yes or no? Are you tell me?
Yes.
These interface is
Yes.
also a part of same port channel. Guys, PC means
Yes.
port channel, not Priyanka Chopra. Okay. So
Yes.
this is also a part of same port channel. So the rule is when switch will receive the packet on any interface, then switch will never forward that packet through those interface which is the part of same port channel. It means this one, and this one. These 3 interface is the part of same port channel. It means this switch number 2 never forward the packet through these interface. Getting my point, everyone? So it means switch number 2 only forward through this one, not why this one. So it means what it will do? It will avoid the loop. And that is called loop avoidance mechanism. That is called loop avoidance mechanism. Getting my point, everyone? I hope
Yes.
you guys understand. Clear? Are you
Yes.
telling me?
Yes.
Okay. This is called loop avoidance mechanism. So I hope now you guys understand actually how ether channel work. What is the problem in the STP? How we solve the problem in STP? There is the protocol that is called ether channel. How ether channel actually solve the problem which was in STP, right? And how ether channel behave, right? Adds
Yes.
in ether channel, what is the loop, how loop will create, and what is the rule to avoid the loop. That is called loop avoidance mechanism. Understand, everyone? Clear? So this
Yes,
is
sir.
something about the guys ether channel. Clear, everyone? Are you tell me?
Yes.
Clear, na? So this is not the last. Tomorrow, guys, we will discuss. There will be a more thing about the STP. We will discuss in tomorrow class about what are the criteria. What are the criteria you have to keep in mind when you are configuring the ether channel. There is some parameter, or you can say there are some rule Getting my
Yes.
point? When we are configuring the Ether channel, we have to keep in mind these things. Getting my point, everyone? After that, we will
Yes.
discuss the types of Ether channel. Types of Ether channel. There are 3 types of Ether channel. We all are discussed one by one. Getting my point? And again, I will tell you what are the types of protocol. In 99% case, you guys will see in the real environment and in the company. Getting my point, everyone? So these
Yes.
things, and once we will discuss these things, I will show you how actually we configure the Ether channel. Getting my point? I will configure all the 3 types of Ether channel in front of you. Getting my point, everyone? And I will show you how we can achieve the maximum bandwidth there and how actually these 3 types of Ether channel work. Clear, everyone? So I hope you
Yes.
guys understand the basic motto of Ether channel. What was the problem? How we solve the things? Clear, everyone?
Yes.
Anyone who do not understand anything?